So section 5.1 in geometry is all about the special pieces of a triangle. So we can have an altitude of a triangle, a perpendicular bisector, an angle bisector, or a median. So an altitude of a triangle is from the vertex of a triangle down to the side opposite of it, and it forms a 90-degree angle. Okay, so if you take the vertex of a triangle and go down to the side opposite of it, it should form a 90-degree angle. That is the altitude of a triangle. Alright, now sometimes in our second triangle over here, see that if I'm looking up here at this vertex, in order for me to form a 90-degree angle, I have to extend this bottom line out, and then I can draw the altitude down by going straight down to form my 90-degree angle. Okay, so altitudes of a triangle are formed from the vertex to the side opposite. Sometimes we have to extend that side out, and it must form that 90-degree angle. And then when we see the word orthocenter, orthocenter here just means it is the intersection point, so here at point H, of the three altitudes of a triangle. So this diagram down here shows the three altitudes of the triangle being drawn out from each vertex, and then their intersection point is called the orthocenter. Okay, the other type, or another type of line we can have is a perpendicular bisector. So let's consider these two words on here. The first part is perpendicular, the second part is bisector. We know that the word perpendicular means 90 degrees, so that means that the line must form 90 degrees. And bisector, we know it means it cuts it equally in two separate parts. So to have a perpendicular bisector, it's going to bisect this line, so it's going to cut it into two equal parts, and then it's going to be perpendicular to it. So that would be a perpendicular bisector. It's showing that the line is drawn through is perpendicular, and it has bisected that. The circumcenter is drawn down here. It is the intersection of the three perpendicular bisectors of a triangle. So on this diagram, each of these lines is a perpendicular bisector of the three sides of a triangle, and then this point J right here where they intersect, that is the circumcenter of the triangle. Next up, an angle bisector. An angle bisector is exactly what it sounds like. It bisects an angle, so if I'm looking from this vertex, and if I wanted to draw the angle bisector, right there would be my angle bisector. I'm showing that it bisects the angle, so it splits it up into two congruent angles. Okay, so it bisects that angle. So if I tell you that this first angle measure here is 25 degrees, so if I tell you that this angle measure is 25 degrees, because it's an angle bisector, that also means that this second angle must be 25 degrees as well. Down here, the incenter is the intersection point of the three angle bisectors. So if you take a look down here, our intersection point of these three angle bisectors is this point G. So G is the incenter. Something also neat that happens with the angle bisectors is that the distance from the incenter to each side, so this XZ, or this GZ, GY, and GX, those three lengths are all the same as each other. So that's just an additional information about the incenter, which comes from the angle bisector. And then this last one here is the median. The median goes from the vertex to the midpoint of the side opposite. Okay, so the median goes from the vertex of a triangle to the midpoint of the side opposite of the triangle. So this would be an example of the median. Alright, and then the intersection of all three medians is known as the centroid. So here's an example of a centroid. We have the three medians of the triangle, and it intersects at this point L, which is at the centroid of point L. So now we're going to do a few examples regarding these four vocab words: median, angle bisector, perpendicular bisector, and altitude. It's going to be important that you understand what these words mean and you are able to identify them with each other. So here for our first example, we see that we have triangle PRS, and we are told that PT is an altitude and PX is a median. So the first thing we need to do is label that accordingly. So if PT is an altitude, altitude means it goes from the vertex to the side opposite, forming a 90-degree angle. So we're going to want to put a 90-degree angle on our diagram where PT comes in contact with that opposite side. Then PX is a median. So median goes from the vertex to the side opposite, and it hits at the midpoint. So that means X is the midpoint of that opposite side SR. Well, if X is that midpoint, that means that SX should have to equal XR. So we also want to indicate that about our diagram. So here it's essential that you understand what the word median means and what the word altitude means so that you can label your diagram correctly. Okay, so once again, PX is a median, so that means X is the midpoint of that side. So since X is the midpoint, that means SX has to equal XR. Now looking at problem 4, we want to find what RS is equal to if Rx is equal to x plus 7 and Sx is equal to 3x minus 11. Well, looking at the diagram we see that we have just finished labeling Sx is equal to xr, and those are also the two equations that we were just given. So since we know that these two must be equal to each other, we can set those two equations equal to each other and solve for x. So x plus 7 is equal to 3x minus 11. So to solve this for x, we will have to subtract the x and add the 11 to both sides. When we've done this, we now get 18 is equal to 2x, so x should equal 9. But when we look at our problem, we want to find out what RS is. So to find RS, we're going to have to plug our 9 back in. Well, if I plug 9 back into Rx is x plus 7, so 9 plus 7, which is 16. So Rx is equal to 16. Now we also know that Rx and Sx are the same, so that means that Sx must also equal 16. So the total distance from R to S should be 16 plus 16, or 32. So Rs is 32. Second part of this problem. Find RT if RT is equal to x minus 6 and the measure of angle PTR is equal to 8x minus 6. Well, so let's look at our diagram. On our diagram, measure of angle PTR, we also notice is labeled as 90 degrees because PT is an altitude. Well, if the angle PTR is 90 degrees and is also 8x minus 6, that means we can create an equation out of this to solve for x. So since angle PTR is an altitude, it's 90 degrees, and we also were given here that it is 8x minus 6. So we can create the equation 8x minus 6 is equal to 90. Now to solve for x, we would add the 6 to both sides. So then we would have 96 is equal to 8x To solve for x, we have to divide both sides by 8. 96 divided by 8 is 12. So here x is 12. But we're really looking for RT. And in our problem, we are told that RT is x minus 6. So 12 minus 6 is 6. So RT is equal to 6. So in order to solve this problem, it was essential that you understood what an altitude meant and what a median meant, so you could correctly solve it. Next one, in triangle DEF, GI is a perpendicular bisector. So we need to know what a perpendicular bisector means in order to solve this. So it means a 90-degree angle. That would make sense at point G. And then bisector, it bisects, it splits it equally, so GE and GF would have to be congruent. So for problem 6, I want to find x if EH is equal to 16 and FH is equal to 6x minus 5. So I can label those on my diagram. So EH is 16, FH is 6x minus 5. Now looking at these, we need to decide how these two sides are related to each other. They should be equal to each other because triangle EGH and triangle FGH end up being congruent by side angle side. So 16 equals 6x minus 5. Most of you should be able to just recognize that they should be equal to each other without justifying why the triangles are congruent. So now we can solve this equation of 16 equals 6x minus 5. To solve for x, we're going to have to add 5 to both sides first. So then we have 21 is equal to 6x, and then we would divide by 6. 21 divided by 6 is 3.5. So 3.5 is our x. Problem 7, we want to find y if EG is 3.2y minus 1 and FG is 2y plus 5. So we're going to start by labeling those two items onto our diagram. And FG is 2y plus 5. We see that we have the mark congruent on our diagram, so we will just make them equal to each other to solve for y. So we'll say 3.2y minus 1 is equal to 2y plus 5. To solve, we'll have to add the 1 and subtract the 2y to both sides. This gives us 1.2y is equal to 6. Divide both sides by 1.2. And we get our y to equal 5. So once again, for this problem, it was imperative that we knew what the word perpendicular bisector meant so that we could ultimately solve for this.